On June 6, 1944, near Rouen, France, Lieutenant Thomas Fraser of the 334th Fighter Squadron, 4th Fighter Group crash landed his damaged P-51B Mustang serial number 4324825, nicknamed Jerry, the Merlin engine, trailed smoke after combat over Normandy beaches. Fraser survived but became a prisoner of war. His aircraft, relatively intact, was recovered by German salvage teams and sent to Rechlin, 100 kilometers northwest of Berlin, for testing. Repaired with parts from other wrecks it wore, Luftwaffe markings, T9 plus HK with RLM-04, yellow paint on tail and undersides for identification. The propeller spinner got yellow paint and a red band adorned the engine cowling. The Mustang joined the Wander Zirkus Rosarius, a specialized Luftwaffe unit that revealed American engineering prowess to German pilots, shaking their assumptions about Allied capabilities and exposing the growing challenges in the air war. By mid-1943, the Luftwaffe faced a strategic crisis. American bombers penetrated deeper into Germany, escorted by fighters whose capabilities were unclear. Combat reports from pilots were inconsistent, often muddled by the chaos of battle. Hauptmann Theodor Rosarius understood the need for systematic intelligence beyond fragmented accounts. In 1943, under General Adolf Galland, orders, he formed the Wander Zirkus Rosarius, officially the second staff of the Versuchsverband Oberkommando der Luftwaffe. This unit tested repairable captured Allied aircraft from France to Italy to the Eastern Front. It went beyond static testing, organizing traveling demonstrations at Luftwaffe bases. German pilots examined enemy aircraft, observed flight displays, and flew mock combats to learn their strengths and weaknesses. The program addressed a critical training gap. German pilots trained against their own aircraft like Bf-109s and FW-190s, using familiar tactics. But Allied fighters like the P-51 had superior range high-altitude performance and different tactical approaches, creating a dangerous blind spot. German salvage battalions operated with precision across occupied Europe. By 1944, thousands of Allied sorties meant frequent captures due to mechanical failures, battle damage, or navigation errors. Fraser ES P-51B sustained minimal damage in its controlled crash landing. German teams reached it within hours, assessed its condition, and transported it to Rechlin, the Luftwaffe's primary testing center since 1936. Rechlin had workshops, test ranges, and runways for evaluation. Technicians repaired the Mustang using parts from other crashed P-51s. The Packard V1650-3 Merlin engine, with a two-stage two-speed supercharger producing 1490 horsepower at 13750 feet, was meticulously restored. The four 50 caliber Browning M2 guns, 2 per wing, were removed and replaced with ballast for safety, hydraulic systems. Fuel tanks and control surfaces were inspected for integrity. The Razorback canopy limited rear visibility compared to later P-51D bubble canopies, but was preserved. After weeks of resourceful work with limited resources, the Mustang was flight-worthy. German test pilots approached the P-51 with skepticism. Shaped by propaganda, American aircraft were portrayed as crude, mass-produced machines prioritizing quantity over quality. But the cockpit U.S. ergonomic design impressed them. Controls were logically placed gauges clear and the seat comfortable, reducing fatigue on long missions. Visibility, despite the Razorback canopy, surpassed the Bf-109's heavily framed canopy. The Merlin engine delivered smooth, predictable power. The four-bladed Hamilton Standard propeller ensured a short takeoff. Roll handling was exceptional. Controls were harmonized with balanced aileron elevator and rudder forces across speeds. The Mustang responded crisply without oversensitivity or instability. Roll rate exceeded the Bf-109 and rivaled the FW-90, enabling rapid maneuvers in combat. Systematic test flights at Rechlin revealed the Mustang's strengths. Climb performance reached beyond 3,000 feet, where the two-stage supercharger maintained power unlike German single-stage engines. Speed hit 440 mph at optimal altitude, outpacing the Bf-109, S-386 IMA and FW-190, S-408. This speed advantage let American pilots dictate engagements attacking or disengaging at will. The laminar flow wing reduced drag-boosting range and efficiency. Dive performance was superior with stable controls at high speeds, unlike German fighters that stiffened in dives. The Mustang could follow German diving attacks, eliminating a key Luftwaffe tactic. Turn performance was complex. The Bf-109's leading edge slats gave an edge in slow, sustained turns, but the Mustang's speed and climb enabled energy tactics. Pilots avoided turning fights, maintaining energy to engage on their terms. Structural strength impressed German engineers. The P-51's robust build withstood battle damage unlike lighter German designs. American engineering prioritized survivability, accepting higher weight for durability. Range astounded German pilots. With internal fuel and drop tanks, the Mustang flew 8-hour missions covering distances impossible for German fighters with 90-minute endurance. This enabled escorts to Berlin and back, closing the window where German fighters attacked unescorted bombers. The drop tanks, often paper-based as developed by Bowater. Lloyd extended range to 850 miles, a revolutionary advantage that transformed strategic bombing. The Wander Zirkus Rosarius toured Luftwaffe bases in late 1944. Demonstrations showcased the Mustang's speed climb and roll rate mock combats against Bf-109s and FW-90s at bases like Jagdgeschwader 1 showed German tactics struggled. The Mustang accelerated away from pursuit's outclimbed attackers and avoided turning fights. German pilots learned to exploit the Bf-109's turn advantage at low speeds, but the Mustang dominated at high altitudes where escorts operated. Test pilots demonstrated American tactics using speed and climb to maintain energy. German pilots found it nearly impossible to engage a Mustang pilot who understood these advantages. The demonstrations were sobering, revealing the Luftwaffe's tactical limitations. German engineers at Rechlin and Göttingen disassembled the Mustang. They studied the wing's aerodynamic efficiency, noting NACA laminar flow airfoils that reduced drag, despite manufacturing imperfections. The Merlin engine, S2-stage supercharger with intercooler, was a marvel, enabling sustained high-altitude performance. Fuel and hydraulic systems were reliable and easy to maintain. High-quality materials like aluminum alloys and rubber contrasted with Germany's shortages. American assembly lines maintained tight tolerances, unlike Germany's dispersed production using forced labor. Using the Mustang design balanced performance and manufacturability, enabling mass production without quality loss. Engineers noted modular construction and standardized components that simplified assembly. American factories produced P-51s with consistent quality, while German production faltered under bombing and resource constraints. The psychological impact was profound. Propaganda about crude American designs was disproven. German pilots faced undeniable evidence of superior engineering. The Mustang's performance eroded confidence as pilots realized they faced faster, longer-ranged, and better handling aircraft. Fuel shortages limited German training to 100 hours for new pilots compared to 200 to 400 for Americans. Experienced pilots were lost faster than replacements could be trained. By late 1944, Luftwaffe losses were unsustainable, with new pilots surviving only a few missions. The Mustang IDS presence over Germany forced pilots to fight superior escorts or let bombers strike unopposed, both grim choices. The Mustang T9 plus HK served until December 10, 1944, when it was lost with pilot Oberleutnant Leochans, possibly in a demonstration crash or air raid. At least 2 P-51s served with the unit coded T9 plus CK and T9 plus HK. Other codes, like T9 plus FK, were a P-47D-A, P-51B trained Hungarian pilots at Nuppen using FW1-70s emphasizing low-speed turn advantages. The program, Elena's knowledge, couldn't ADT reverse Germany's decline. Fuel shortages, production issues, and numerical inferiority crippled the Luftwaffe. American production hit 500 P-51s monthly by late 1944, peaking at 881 in January 1945. German fighter production was half that with declining quality. The Mustang's maintenance impressed German crews. The Merlin engine's cowling opened for easy access to systems unlike the Bf-109's complex servicing panels allowed quick repairs ensuring high availability. American emphasis on maintainability kept aircraft combat ready. German aircraft suffered from parts shortages and dispersed maintenance. The Mustang's reliable engines, accurate instruments, and effective radios outclassed German equipment. American pilots were supported by robust logistics and thorough training. German pilots faced impossible odds at high altitudes. The Wanderzirkus Rosarius operated into 1945, but Allied advances limited its reach. Captured P-51s were destroyed or recaptured as Germany collapsed. The program provided tactical insights but couldn't overcome Germany's disadvantages. German fighter production fell 40% and fuel production 90% by late 1944. The Mustang's range high-altitude performance and speed made bomber escorts sustainable, reducing Allied losses and enabling relentless bombing. German test pilots developed grudging respect for the Mustang's design. It sacrificed turn performance for speed range and high-altitude capability, perfect for bomber escorts. The aircraft's ease of production and maintenance reflected American industrial strength. German attempts to counter with advanced designs like the FW-90D or Me-262 failed due to production delays and resource shortages. The Me-262's speed was formidable, but engine reliability and fuel demands limited its impact. Fraser's P-51B from a French field to Luftwaffe bases challenged German assumptions. Its testing exposed the gap between propaganda and reality. The Wanderzirkus Rosarius showed professional intelligence gathering, but Germany's material and strategic limits were insurmountable. The Mustang's legacy was its decisive role in Allied air superiority. American designers created a mission-focused aircraft produced in vast numbers with consistent quality. Thorough training and logistics ensured its effectiveness. The program's insights confirmed Allied advantages in industrial capacity, resources, and technology. German pilots faced a stark reality: superior opponents in every critical area. The Mustang proved that well-designed mass-produced aircraft could win the air war.